Okay, so problem. A rectangular section having dimensions of 100 mm by 200 mm is subjected to a shear force of 50 kN. Determine the shear stress induced on a layer of 50 mm above neutral axis and at any. Sketch the shear stress distribution diagram and calculate the average shear stress. So first of all, write down the given data. A rectangular section having dimension width it is given b is equal to 100 mm. Width 100 mm. And depth of this section it is d is equal to 200 mm. Okay. So shear force S is equal to it is given S is equal to 50 kilonewton. 50 kilonewton. So convert it is in kilonewton to newton. That is 50 into 10 to the power 3 newton. Okay. So first of all, draw the section of this beam. So this one it is rectangular section. Its width it is b is equal to it is 100 mm. 100 mm. And depth it is depth t is equal to this one it is depth it is given d is equal to 200 m 200 m. So location of neutral axis, just show the neutral axis it will be d by 2. This one it is neutral axis. Okay. Just show this one it is neutral axis. This one it is any neutral axis. Any. Okay. Neutral axis. So neutral axis it is located d by 2. D by 2 from top and d by 2 from bottom. So this one it is d by 2 means this one it is 100 mm above the neutral axis, and below the neutral axis it is 100 mm. Below the neutral axis it is 100 mm. 100 mm. Okay. So first question, determine the shear stress at. First question, shear stress at 50 mm above the neutral axis. 50 mm above 50 mm above neutral axis. 50 mm above the neutral axis. So this one it is neutral axis. So 50 mm above the neutral axis. So we need to calculate shear stress here. Okay. This one is we need to calculate shear stress here. You just assume this one it is PQ. This point just assume this one it is PQ point. P and Q. Okay. P and Q point. Okay. So I will show this one it is different. Okay. So we need to calculate shear stress for this portion. Okay. For this portion only. Okay. So now, so for this area it will be, so depth of this color portion it is 50 mm. So this portion it is depth it is 50 mm. This size it is 50 mm. This one and this one it is 50 mm. So total it is 100 mm. That's why it will be divided into two parts. That is 50 mm. Okay. So first of all, area of this portion A is equal to it will be 50 into 100 mm. 50 into 100 mm. So it will be how much? 50 into 100. So it will be 5000 mm square. 5000 mm square. 5000 mm square. Okay. 5000 mm square. Then y bar it is. Okay. Y bar it is for the this portion, color portion. Y bar it is 50 plus 50 plus 50 by 2. 50 plus 50 by 2. 50 by 2. 50 by 2. 50 by 2. Okay. So Q50 you can say it will be Q50 or PQ is equal to formula for the SA S A y bar divided by S A y bar divided by this one, it is shear stress equation, S A y bar divided by IB I into B. Okay. So I it is BD cube by 12. So we calculate here I is equal to this BD cube by 12. So B into D cube, B into D cube, B into D cube divided by 12. B into D cube divided by 12. Okay. Is equal to B, it is here 100 mm and D it is 200 mm. D it is 200 cube divided by 12 divided by 12 divided by 12. Will get moment of inertia for that 100 into 200 cube divided by 12. It will be 66.67 into 10 raised to the power 6 mm raised to 4 mm raised to 4 mm raised to 4. Okay. So just put all this value here is equal to shear force, it is given S is equal to 50. Put all this value in Newton M. Okay, 10 raised to power 3. S it is in kilonewton. We have converted it is in Newton. Area it is 5000 mm square. Then B it is width it is Y it is 50 plus 50 by 2. So how much this one it is? 50 plus 50 by 2, it will be 75. 75 and so here Y is equal to Y bar it is 75 divided by IB. I it is 66.67 into 10 raised to the power 6 into B it is width it is 100 mm. Width it is 100. So it will begin Q50 here. So just calculate 50 into 10 raised to power 3 into 5000 into 75 divided by 66.67 into 10 raised to power 6 into width it is 100. So it will be 2.812. 2.812 Newton per mm square. Newton per mm square or MPa or megamas. So I will note down this one value. Q50 is equal to will be 2.812 MPa or Newton per mm square. Okay. So now calculate shear stress at neutral axis. Okay. Right here. Second equation. Okay. Shear stress at neutral axis. Okay. So this field is neutral axis. So now second question. Shear stress at neutral axis. At neutral axis. Okay. So this one it is neutral axis. So just now consider portion for them. So above the neutral axis. So this portion it is above the neutral axis. Just consider above the neutral axis. Now consider this portion only. Okay. For this calculation. So first of all, area it is 100 into, only consider this red portion for area. Area into 100 into 100. 100 into 100, it will get how much? 100 into 100. It will be 10,000 mm square. 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 So now y bar here, y bar is equal to this 100 divided by 2. That is depth by 2. 100 by 2. Okay. 100 divided by 2. 100 divided by 2. Okay. 100 divided by 2. This red portion depth it is 100 mm. So that's 100 divided by 2. This one it is 50 mm. 50 mm. Okay. So now QNA is equal to, so equation this one it is again SA y bar divided by IB divided by IB divided by IB is equal to, so now yes it is 50 into 10 raised to power 3, 10 raised to power 3. Area it is 10,000 mm square, 10,000 mm square. Y bar it is 50 mm. SA y bar divided by IB. So I we are calculated. I it is we are calculating this one it is 66.67 into 10 raised to power 6. Then width again width it is 100 mm. So it will get QNA from this. It will be calculated just 50 into 10 raised to power 3 into 10,000 into 50 divided by 66.67 into 10 raised to power 6 into 100 mm. So it will be 3.74 3.749 Newton per mm square, Newton per mm square or MP. Okay. MP. So just note down this units. QNA is equal to 3.749 MP or Newton per mm. So now next question, calculate average shear stress. So Q average is equal to it is S by A. Yes, shear force divided by cross-sectional area of beam. Shear force divided by cross-sectional area of beam. So it will be, yes, it is 50 into 10 raised to power 3 divided by area it is, area it is 100 into 200. 100 into 200. So K average it will be get how much? Q average is equal to 50 into 10 raised to power 3 divided by 100 into 200. It will be 2.5 Newton per mm square. Newton per mm square or MPa. Okay. Or MP. So we will note down this unit also. Q average is equal to 2.5 MPa. Okay. Yeah. Now draw the shear stress diagram. Okay. Next question is draw the shear stress diagram. So we draw the first cross section of this beam. This one is cross section of this beam. Then this is neutral axis. I'll show this one it is shear stress diagram across the cross section. Okay. This one it is shear stress. So maximum shear stress it is occur at the neutral axis. Okay. So this one it is maximum shear stress it is at neutral axis. So this value it is QNA or Qmax. You can say it will be QNA or Qmax. Qmax is equal to it is how much? 3.749 MPa or Newton per mm square. Then at 50 mm above the neutral axis. So this distance it is. Yes, so this one it is. This one it is. Q50, you can see it will be Q50 or Q50 is equal to this. So this one it is 2.812 MPa. Yeah. This one it is shear stress diagram. So actually ratio of Qmax or QNA, ratio of Qmax and QNA, it must be Qmax or Q average, sorry, Qmax or Q average. So this ratio must be 1.5. So Qmax it will be 3.749 or QNA 749 divided by Q average it is 2.5. 2. So this ratio must be 1.5. Okay. Just I will cross check 3.749 divided by 2.5. So it will be 1.499. This means 1.5. 1.5. Your answer it is correct. Okay. So this one it is cross check. Okay. I hope this one it is cross check. This one. Okay. So actual we need to calculate Q50 means QPQ, that is 2.812 MPa, and Q average it is 2.5 MPa, and QNA that is Qmax you can say also 3.749 MPa. Okay, this is your final answer.